I welcome you all to the session of engine system and performance, and in today's class we shall discuss about electronic fuel injection system, and thereafter we shall see different types of injection schemes. So, we have discussed about ignition system and ignition circuit in our previous class, and we had seen that electronic control unit, which is a very important part of modern engines. So, what we had understood that ignition circuit is important to provide or to control the spark timing of each and individual cylinder. Now, fuel injection is also very important from the perspective of engine efficiency and better emissions or emission control rather. So, fuel injection, that is injection of fuel or required quantity of fuel at a perfect time to all the cylinders in a multi-cylinder engine is very important, as I said, from the perspective of higher engine efficiency and better emission. So, you know that electronic control system or ECU for the process of fuel admission is assembly of a few sensors, fuel injector assemblies and wiring. So, we shall discuss today that this fuel injection system, which is also should be controlled by the electronic control unit, essentially to control the injection time, and then injection time should be based on the engine speed and also the ignition timing. So, all these things will be taken care by the electronic control unit, and in this particular part of this ECU, that is electronic fuel injection system, as I said you, is containing a few sensors, fuel injector assemblies and wiring. So, let us now write a few important points for this particular part, and then we shall discuss their objective of each and every component like sensors, fuel injector assemblies, and certainly if we need to convey some message to the sensor from the ECU, or if we need to receive some message from sensor to ECU, we need to have wiring arrangements. So, as I said you that electronic control system for fuel admission process is assembly of a few sensors, fuel injection assemblies and wiring. Now, you know that this electronic fuel injection system, if I write system, in short we can write EFI. This particular system again works on some feedback will be received from a few sensors, and then receiving those signals from the sensor, ECU will do some intermediate steps to control the pulse width or width of the injection pulses. So, if I write now here that ECU or inputs are received from the sensors. In fact, it is not a particular sensor, rather several sensors. Then receiving these inputs, ECU determines the basic pulse width. Now, after determining the basic pulse width, it will be then corrected for a few considerations. So, if I write that point also, right, then so basic pulse width of an injection pulse. The basic pulse width is then corrected. So, basic pulse width is then corrected for several consideration. What are those considerations? So, essentially that ECU will receive inputs from several sensors. Based on those inputs, ECU will determine a basic pulse width of an injection pulse. So, the basic pulse width needs to be corrected, needs to be modified for several considerations. Like that those considerations are the width what should be determined finally by the ECU should be such that proper amount of fuel should be injected. So, it is not only that the ECU will determine the pulse width based on a particular consideration. It can be due to the oxygen present in the exhaust gas. So, this particular consideration should be taken into account. Also, the amount of heat to be or is getting or being supplied to the coolant, this factor should also be taken into account. Then engine speed. So, all these considerations are taken to correct or modify the basic pulse width, right. And then when the basic pulse width is corrected, electronic control unit or ECU will issue a current pulse that will actuate the solenoid based actuator of the ECU, essentially for the desired pulse width of the injector. So, let me tell you once again, after correcting the basic pulse width, what does ECU will ECU do is that ECU will issue a current pulse that will actuate the solenoid based actuators of the ECU itself, essentially for the desired width of the injector pulse. So, if I write here briefly, then ECU will issue current pulses that will actuate its solenoid based actuators for the specified or desired pulse width. Okay. So, this is how an electronic fuel injection system works. So, the the main idea behind having electronically controlled fuel injection is to provide adequate amount of fuel to each and every cylinders in a multi-cylinder engine at a proper time, so as to maximize the engine efficiency and also to reduce emission. So, now question is, what we have seen, we have written here that inputs are received from several sensors, and the sensors that report to the ECU are basically engine speed sensor, then air intake air temperature sensor, manifold air pressure sensor, throttle position sensor, the sensor which is used to measure the sense the presence of oxygen in the exhaust gas, also the sensor which is used to measure the coolant temperature. So, all these sensors are used, or all these sensors report to the ECU, and receiving inputs from all these parts of the engine, this process is executed by the entire process is executed by the electronic fuel injection system, essentially to allow the injector to admit required amount of fuel at a desired or at a proper time, so as to minimize fuel loss, which in turn will maximize the engine efficiency and will reduce the fuel emission. Now, question is, that if we go to the next slide, so we will be discussing about different types of injection schemes, but before going to discuss about different types of injection schemes, let me write here what are the different types of injection scheme. So, and also very important to know at this juncture is that the sensors which are used or which are essentially important for the proper functioning of fuel injection system is are engine speed sensor, throttle position sensor, manifold manifold air pressure sensor, cooling water or coolant temperature sensor, and then intake air temperature sensor, which is used to measure or sense or to understand the temperature of intake air and pressure. All these sensors are used to provide some feedback to the ECU, and based on these feedbacks ECU determines the basic pulse width. That is what we discussed. Now, the question is, so far we have understood that the pulse width of an injector is very important, that is the time duration over which an injector will deliver fuel to a particular cylinder, right. So, the frequency of the pulse width is very important, and we shall now try to understand what should be the frequency of pulse width of a particular injector. So, before coming to this part, let me write here the frequency of an the injector pulses is derived from the engine speed. Right, and as I said you, the sensors that report to ECU in connection with electronic fuel injection system are engine speed sensor, then we have discussed manifold absolute pressure sensor or MAP, manifold absolute pressure sensor, throttle position sensor, and then engine coolant temperature, inlet air temperature and all these things. Engine so let me erase this part. Engine coolant temperature sensor, etc. And also that is I told you intake air temperature and pressure sensor, and sensor which is used to check the presence of oxygen in the exhaust gas. Now, the frequency of the injector pulses is derived from the engine speed, and you know that so engine speed is very important. So, similar to ignition circuit that we have discussed in one of our previous classes, similar to ignition circuit, ignition pulses, we have seen that ignition pulses are basically ignition pulses from the negative side of the ignition coil is used to determine the engine speed and also the pulse width of the or width of the injector pulses. So, let me repeat once again, we have discussed this part in the context of ignition circuit or ignition coil, and similar to ignition circuit, ignition pulses from the negative side of the ignition coil determines the engine speed as well as pulse width of the injector pulse or injector. Now, essentially what do we mean is ignition pulses are passed. So, ignition pulses are used to determine the frequency of the injector pulses. So, if I write here ignition pulses are fed to the pulse shaper which generates rectangular pulses, pulses from the triggered pulses. Right. So, ignition pulses from the negative side of the ignition coil determines the engine speed and also the frequency of the injector pulses. So, the idea behind this discussion is ignition pulses are responsible to determine the frequency of the injection pulses or injector pulses. What is pulse width? The time duration over which an injector would be able or will deliver fuel to a particular cylinder of a multi-cylinder engine, right. So, essentially the frequency of the injector pulse, which is very important for a particular engine, ECU should know what should be the frequency of the injection pulse, right, and that frequency of the injection pulse is determined from the ignition pulses, and which in turn also depends on the ignition circuit. So, essentially a proper operation of electronic fuel injection depends on the proper functioning of the ignition circuit or ignition system. You can understand from your basic understanding of internal combustion engine course that in a 4-stroke engine, intake valve is, when intake valve is open, then fresh charge, or if it is a CI engine, fresh air is drawn into the engine cylinder. Now, when fresh air is coming into the engine cylinder, what is done essentially, that either fresh fuel air mixture is coming, or if it is a CI engine, then air is coming and in the manifold itself fuel is sprayed. Okay. So, the time over which the fuel injector will spray fuel, that is essentially the width, pulse width, and how frequent that particular injector will operate in a particular cycle, that frequency of the pulse width depends on the ignition. So, essentially that we need to ignite the fuel air mixture if it is a SI engine or petrol engine, and then depending on the ignition pulses, this fuel injection pulse is controlled. Okay. And as I said that different types of injection schemes. If I write here the injection scheme, so there are different types. So, what is a injection scheme? As I told you, injection time, that is the time over which fuel injection fuel will be delivered, fuel will be sprayed. So, this injection timing control, if I write here, injection timing control determines when each injector will deliver fuel to its corresponding intake port. Right. So, that is the injections. So, basically this is important consideration based on which there are several injection schemes. So, injection timing control determines when each injector will deliver fuel to its corresponding intake port. As I showed you that if it is a case that we need to supply fuel or we need to spray fuel in the intake port with the fresh air that would be drawn into the engine cylinder. So, when that particular injector needs to supply fuel, when a particular injector needs to deliver fuel, that is determined by the injection time controller, right. So, now we shall discuss a few different types of injection schemes, whether we need to supply or whether we need to inject fuel simultaneously to each and every cylinders in a multi-cylinder engine, or if we need to deliver, if we need to design a fuel injection system, electronic fuel injection system in such a way that in a multi-cylinder engine injectors will deliver fuel in a sequential manner, or it may be required that an individual fuel injector is needed for each and every cylinder. So, depending on the amount of fuel to be supplied, when a particular injector will deliver fuel to its corresponding intake port, based on this injection essentially controller, injection timing controller or injection time controller which is used to control that time will determine. So, now we shall be discussing about a few injection schemes before we stop our discussion today. The first is simultaneous injection. From the name itself you can understand that. So, if I write here simultaneous fuel injection, so this is a type of injection scheme. Let me write here. This is a type of multi-point, I said say multi-point injection scheme. I should write multi-point fuel injection, right, that injects fuel to all or into all cylinders at the same time, into all at the same time, right. So, if we go back to the previous slide, so then if we talk about a simultaneous fuel injection, from the name itself you can understand that fuel injections should be simultaneous. So, if there are 6 engines, if there are 4 engines in all these cylinders of a multi-cylinder engine, schemes should be able to supply or inject fuel at a given time or at the same time, right. So, if we go back to the previous slide wherein a schematic depiction of this particular scheme is there, what you can see that it is simultaneous petrol injection. I mean if it is a petrol engine, then you can see that several symbols are used to indicate whether the valve is when the valve is open, petrol injection and ignition. So, you try to understand petrol injection, that symbol is at a given time. So, for example, if it is 0 degree, this is 360, this is 720 and like this. So, what we can understand at a given instant, this particular following this particular scheme, it is possible to inject fuel to all cylinders. So, there are 4 different cylinders that you can see, right. While try to understand that this is the ignition, this symbol is used to indicate ignition. So, though it is possible to inject fuel at the same time to all 4 cylinders, that is evident from the schematic depiction. Ignition is when ignition is cylinder 1, then there is no ignition in so when ignition is cylinder 3, there is no ignition in cylinder 1 and 1, 2 and 4 like this. So, it is kind of simultaneous injection. So, this is the most common type injection system, as I have written that this is the simplest. So, this scheme, this is the simplest scheme and most common injection timing method. in use, right. Now, I said that if following this particular scheme, if we need to supply or if we need to inject fuel at the same time to all cylinders in a multi-cylinder engine, then what should be the hardware? I mean, how come it would be possible to inject fuel to all cylinders in a multi-cylinder engine? So, if I write here now again, so this is, so here I can write multiple fuel nozzles are used to work together to inject fuel into all cylinders at the right time or at the same time, I should say, right. So, there are multiple fuel nozzles, all nozzles should be actuated by the solenoid based actuators of ECU to function at the same time, so as to fuel can be injected to all cylinders or into all cylinders at the same time, right. Okay. Next is basically it is sequential injection. So, again it is depicted schematically this particular scheme, that is sequential injection. Okay. And you can understand, let me write a few words for this and then I will discuss. This is also most common type, Number 2 is most effective injection scheme, and sequential. From the name itself you try to understand that following this scheme it would be possible to inject fuel sequentially to the cylinders in a multi-cylinder engine. Okay. So, this is the scheme is used to deliver or inject fuel to each cylinder at the right time right. If it is possible to inject or deliver fuel to all cylinders at the right time, then perhaps we can ensure a proper combustion, provided the stoichiometric air fuel ratio or closer to stoichiometric air fuel ratio is maintained and adequate air temperature is maintained, then efficiency of the engine can be increased. So, it improves or increases engine efficiency and reduce emission. So, these 4 points are very important points for particular type, and from the name itself, as I said you, sequential injection. So, it is not a simultaneous injection. So, from the schematic depiction again we, the same type or same symbols or same symbol is used to indicate intake valve open, petrol injection and ignition. So, what you can understand, so at a particular instant, say for 0 degree crank rotation, 360 degree and 720 degree crank rotation, you can see that petrol injection takes place sequentially, right. So, when injection is there in cylinder 1, then there is no fuel injection in remaining other 3 cylinders. So, this schematic depiction is essentially for the sequential injection scheme to 4 different cylinders, and you can see when a particular cylinder is getting fuel or the scheme or the fuel injector is injecting or delivering fuel to a particular cylinder, then there is no fuel injection in the remaining cylinder at a particular instant of time. Okay. So, now as already you have listed down a few important points for this particular type, and since it is possible to inject fuel at a right time, we can maximize engine efficiency, and if we can maximize engine efficiency, which is equivalent of saying that emission can be reduced or can be controlled. Okay. Next, I will be talking about grouped injection. So, let me write a few lines or points about this. Here, number 1 is injectors are grouped into pairs. Then 2 is the pair injectors are grouped into pairs. So, 2 cylinders will use one pair, right. If it is a 4 cylinders engine, that particular engine will use 2 different pairs. 6 cylinders engine use 3 different pairs. So, the pair consists of two consecutive cylinders, that is what I said just now in the firing order. Okay. And each pair is driven by a separate by a separate circuit, separate driver circuit. It is not a case that a common circuit will be used to drive all pairs in a grouped injection scheme. So, following this scheme, injectors are grouped into pairs. The pair consists of 2 consecutive cylinders in the firing order. So, cylinder 1 should be fired first and then cylinder 2 will be fired. Each pair is driven by a separate driver circuit, that is very important. So, you know that for the simultaneous fuel injection system that we had seen over here, that particular for this particular system, basically what is done, we need to have certain pulse for the injectors, right. So, all injectors for this particular type, that is simultaneous fuel injection, for this particular type of injection scheme, all injectors are pulsed by a common driver circuit. So, that is what I forgot to mention. Now, I will write here. So, I may mention here that all injectors are pulsed by a common driver circuit. So, that is very important. Okay. So, it is not a case that every injector will be having a separate driver circuit. So, that is why it is the simplest one. So, now we should come back to our discussion on grouped injection. Each pair is driven by a separate driver circuit, right. Now, as I mentioned that if it is 4 cylinder engines, for example, I mean since injectors are grouped into pairs. So, 4 cylinder engines use 2 different pairs, 6 cylinder engines used will use 3 different pairs, all these things. Now, so important point that I should write for this particular scheme is, let me write here that in injection certainly fuel injection is timed to deliver or inject the fuel immediately preceding the intake stroke for leading cylinder in the pair. Right. As I said you 4 cylinders engine use 2 different pairs. So, each pair is responsible to supply fuel into 2 different cylinders, and what it is written over here, fuel injection is timed to deliver fuel immediately preceding the intake stroke for leading cylinder in the pair, right. Okay. And another important point is, just I am mentioning, you should know the entire group, I mean if it is 2 pairs, 3 pairs. So, the entire group is pulsed 1 per engine cycle. The entire group is pulsed 1 per engine cycle. So, following this injection scheme, rather the timing or ignition timing, the injection timing, following this scheme, the timing method, essentially we have discussed about 3 different schemes. So, what we are trying to say in a way is timing method. So, following this scheme, the timing method ensure that fuel injection or fuel delivery does not linger behind the intake valve. So, that will reduce the emission. So, just if I write here somewhere that, so following the grouped injection or timing method, right. Following the grouped injection timing method, fuel does not linger behind the intake valve. So, thereby this particular aspect reduce emissions. So, this particular aspect reduce emissions. Okay. So, this is what is very important point. So, injection time does not allow or ensure fuel ensure that fuel does not linger behind intake valve. Okay. So, if it is a case, then certainly we can reduce emissions. Then final scheme is independent injection, that you have studied in your basic IC engine course. So, this is the last one, is independent injection. So, let me write a few words for this particular type, then I will discuss. So, following this scheme, injectors are driven independently and sequentially by separate driver circuits. Number 2 is injection is timed to deliver entire fuel just prior to each intake valve opening. Okay. So, from these two particular characteristic features, we can say that this particular timing method provides optimum engine performance in terms of emissions and fuel economy. Okay. So, let me now explain to you all. So, following this timing method or scheme, injectors are driven independently and sequentially by separate driver circuit. So, try to understand, injectors are driven separately and also sequentially. So, if it is a multi-cylinder engine, so for each and individual cylinder we will be having a dedicated injector, and all injectors are driven independently. So, and also sequentially, it is not a case that when cylinder 1 will be receiving fuel, cylinder 2 will not, like this. And injection is timed to deliver entire fuel just prior to each intake valve opening. So, basically that control should be done by ECU, so that entire fuel amount or fuel mass should be injected before intake valve opening. So, accounting for these two important or distinctive features, this particular scheme provides optimum engine performance because of entire fuel is injected just before the intake valve opening, and we can reduce, first of all it is sequentially and individually. So, we can meter or we can supply metered quantity of fuel to each and individual cylinder. So, that way we can bring fuel economy, and second thing is we can reduce fuel or better emission, because see that emissions should be, if it is that we have discussed in the context of previous two method, that right time. So, if a particular cylinder is having a dedicated injector, then it is possible to deliver or inject fuel at a right time. If it is a case, then we can bring in, we can establish or we can ensure better fuel economy as well as reduce fuel emission. So, to summarize our today's discussion, we have tried to understand about electronic fuel injection system or EFI. Electronic fuel injection system is a part of electronic control unit, and this in the context of electronic control system, the fuel admission process is assembly of a few sensors, injector assemblies and wiring. So, all these parts together form the electronic fuel injection system. We have seen that this particular unit should work based on the inputs that inputs will be received by a few sensors from several parts of the engine, and receiving signals from several sensors, ECU will derive the basic pulse width first. It will be corrected then based on a few considerations, and then the final width will be derived. And then most important part that we have discussed is the frequency of the pulse width, that how frequent that injector will be under operation. So, that is also determined by the ignition pulses that we have seen, and thereafter we have discussed a few schemes or injection timing method typically used for the engines. So, with this I stop here today, and we shall continue our discussion in the next class. Thank you.